Welcome to This Explainer. Today, we're diving into the hidden vulnerabilities lurking just beneath the surface of modern AI systems. I'm really excited to guide you through this, because let's face it, we all interact with AI every single day, usually without a second thought. But beneath that sleek, super helpful exterior, there's some pretty significant risks we need to unpack. We'll be pulling data and examples straight from our source material to really break this down.
Okay, here's our roadmap for today. We'll quickly cover the unseen AI risks in general, then dive into privacy, as in who actually has your data. After that, we'll look at security and hacking the AI, followed by fairness and the bias problem, before finally wrapping up with how we can secure our AI future.
So, Part 1, the unseen AI risks beneath the surface.
Based on our source data, there are exactly three core pillars of risk we really need to focus on today: privacy, security, and fairness. And look, these aren't just abstract, theoretical tech problems reserved for Silicon Valley developers. These are real-world challenges that directly impact our bank accounts, our daily routines, and honestly, our fundamental rights. We're talking about the very infrastructure of modern life. Understanding these vulnerabilities is absolutely the first step to taking back control of our digital footprint.
Moving right along to Part 2, privacy concerns, and the big question, who actually has your data?
Is your smart home assistant keeping secrets, or is it basically the ultimate neighborhood gossip? It's a question we absolutely have to ask ourselves. We constantly trade our locations, our browsing history, our voice recordings, even our biometric data, all for the convenience of, asking a machine about the weather. But where does all that data actually go? It's so easy to forget that the little speaker sitting on your kitchen counter is essentially a constantly running microphone feeding massive remote servers.
The fundamental threat here is pretty straightforward. AI absolutely needs vast amounts of data to function. It's the fuel for the engine. An AI without data is basically like a sports car without gas. It's just not going anywhere. But processing all this fuel without explicit user consent, that exposes highly sensitive, deeply personal information to potential misuse. And as we'll see, that leads directly to some massive regulatory headaches.
Just think about a casual, private conversation in your living room. A smart assistant inadvertently records it, and suddenly that audio file is just sitting on an accessible cloud server somewhere. This takes the risk from some abstract theory to a very real, honestly very creepy, invasion of your home. And the crazy thing is, it's not necessarily a malicious hacker in a dark hoodie doing this. Sometimes it's just sloppy corporate data storage policies, leaving your most private moments completely exposed to unauthorized personnel.
The fallout here goes way beyond just a creepy feeling. It escalates incredibly fast to identity theft and then to massive regulatory penalties under strict frameworks like Europe's GDPR or California's CCPA. These laws have real teeth, and we're talking about fines in the millions for mismanaging consumer data. But ultimately, an incident like this completely shatters user trust. If we don't trust the technology we're bringing into our homes, the entire ecosystem just collapses.
We aren't helpless, though. To build a solid defense, organizations have to step up. First, they need to implement strong encryption to lock that data down. Second, practice data minimization, which basically means only collecting what is absolutely necessary to get the job done. Add to that rigorous user consent management, which gives the power back to us consumers so we know exactly what we're agreeing to. And finally, strict access control and auditing. If we do all that, we can ensure that what gets collected stays fiercely protected.
All right, let's jump into Part 3, security, and specifically, hacking the AI.
So what actually happens when an AI platform's API is compromised? Think of an API as the software bridge connecting the AI to our data. It's how different programs safely talk to one another. But what if that bridge becomes the exact entry point for attackers? It's kind of like putting a state-of-the-art 6-foot-thick steel vault door on a bank, but leaving a side window wide open.
Because despite how incredibly advanced and futuristic it seems, AI is ultimately still just software. It's built on code, and like all code, it contains vulnerabilities and hidden flaws that hackers love to exploit. They use these weak points to hijack predictions, gain unauthorized access to networks, or siphon out highly confidential information. AI suffers from the exact same foundational security risks as any traditional computer system out there.
Consider this deeply troubling scenario straight from our sources. A healthcare AI platform gets compromised through an insecure API, allowing attackers to access patient medical records. Now, this isn't just about losing a streaming service password or getting a bunch of spam emails. This is deeply private medical history, diagnoses, treatments, personal identifiers exposed in an instant. The stakes literally couldn't be higher when human well-being is on the line. The cascading impact of a breach of this magnitude is just enormous. We're looking at devastating financial losses, permanent reputation damage for the institutions involved, and massive service disruptions. And keep in mind, in fields like healthcare, where system uptime is absolutely critical, a disrupted network doesn't just mean a minor inconvenience for IT. It can quite literally be a matter of life or death for the patients relying on that system.
To lock this down, organizations have to execute a relentless procedural defense. This means deploying things like secure multi-factor authentication and constantly running penetration tests. That means actively hiring ethical hackers to try and break into your own systems to find those weak spots before the bad guys do. It also requires obsessively pushing out regular security updates. It's a constant, ongoing arms race. Which brings us to part 4, fairness and the bias problem. Can an algorithm actually learn to discriminate? Now, we naturally assume computers are perfectly objective, right? They're just cold math machines crunching numbers. But what happens when the numbers they crunch, those massive data sets they're trained on, come from a flawed historical reality?
You see, AI models are essentially mirrors. They learn from historical data. So if historical banking or hiring data reflects existing human discrimination, the AI doesn't just magically correct it. It simply automates and amplifies that unfairness at a massive, incredibly rapid scale. It's a classic case of garbage in, garbage out. But in this highly sensitive context, the garbage we're talking about is historical prejudice.
Ideally, we want totally unbiased outcomes. We want equal ranking for genuinely qualified candidates or identical credit scores for similar financial profiles, regardless of what zip code they live in. But in reality, biased AI does the exact opposite. It penalizes certain neighborhoods or consistently favors male candidates based purely on historical hiring trends. The machine literally learns how to redline, hiding its discrimination behind a shiny veneer of mathematical objectivity.
The real-world damage here is profound. Biased AI leads directly to systemic discrimination in hiring and totally unfair loan rejections in finance. This triggers serious legal issues, invites intense regulatory scrutiny, and drives even deeper social inequality. Because let's be real, when people realize a machine is stacking the deck against them, it completely destroys any public confidence in the institutions deploying these models.
Defending against this bias requires active, intentional intervention. We have to utilize truly diverse data sets and run strict fair lending audits and bias testing to catch discrimination early. It also requires implementing explainable AI, or XAI, so we can actually understand the model's logic step by step instead of just blindly accepting a black box answer. And above all else, we must mandate human review and independent validation. We just cannot blindly trust the machine to make these critical decisions on its own.
Finally, Part 5, Securing Our AI Future. I'll leave you with this provocative thought from our explainer today. As AI continues to rapidly evolve, are we building systems that serve everyone safely and fairly, or are we just accelerating our own historical flaws? The power of artificial intelligence is absolutely undeniable, but the responsibility lies entirely with us to ensure this technology is as safe and fair as it is powerful. Keep this in mind the next time you interact with an AI. Thanks for joining me on this deep dive.